Okay, today we're going to talk about quadratic problems that are going to relate to things that you might be talking about in the real world. To help us out, we have a visual here. So as we are doing the problems, we're going to refer back to the visual. And to help us get numbers, we are also going to use Desmos again. So let's go down to example number 1. Okay, for example number 1, we're going to go to Desmos and we're going to type this in. Now, the first thing you need to know is that decimals will only work with the letter X. So if you see a letter T, please change your T's into X's. So I'm going to go over here and I'm going to type in negative 16x to the second plus 128x. So remember, type in X's, not T's. And then we're going to have to adjust things. So we're just going to keep adjusting things around. You can keep scrolling, you can change other things, but we gotta go way up here, getting closer. Oh, there we go. At least for parts of it anyway. All right, so back here. How long will it take the toy rocket to reach its highest point? So let's look back at my visual. Okay, the highest point is going to be part of the vertex. Now, it's not asking how high is it. It's asking how long will it take to reach that. So I'm asking for the x value, the horizontal distance. So when you look at the vertex, if you look over here, do you see it says next to the x, let me get a pen. Next to the x value, it says that is when is the object at the max height. So if I ask for when is it or how long it will take, that is the x value of the vertex. So x value of the vertex is what we normally call line of symmetry. So the hardest part is going to be reading the statement of what you're trying to do and then figuring out what does that mean to me. So how long does it take to get to the highest point is always the line of symmetry. And remember, the line of symmetry is the x value of the vertex. So here's my vertex, and the x value is 4. So it will take, t is in seconds, so it will take 4 seconds. Okay, the next one. What is the highest point? Okay, so if I go back to my visual, if I look over here, it says, change pen color. It says how high does the object go? That is the y value of the vertex. Okay, so this is the max, which is the y value of the vertex. So if I go back to my picture, the y value is 256. And then label, doesn't really have a label here. So, oh, in part C, it does talk about feet. So we're going to say feet. All right. If a bird was flying overhead at 275 feet, is it possible that the rocket would hit it? Well, the answer for that one, we get to use the fact that in B, we said the highest it will go is 256. 256 is below the bird, so it will not hit it. So I would say no. The highest the rocket will reach is 256 feet, which is below the bird flying at 275 feet. Okay, you must explain. It does say explain, so you can't just put yes or no. If you only put yes or no, you won't get full credit. So please make sure you include the explanation part along with it. All right. When will the rocket be 112 feet off the ground? Okay, so I'm telling you the height is 112. So height is always the y value. So I'm basically telling you y is 112, and your job is to tell me the x value at 112. Okay, so back here to Desmos, 112. Gonna keep scrolling to 112. Okay, so here's 112. So if I go across, whoops, why will it not? Okay, if I go across, it looks like it's out about 1 second on the way up, and then it's also going to hit 112 again on the way down, and that is at about 7 seconds. So we've got 1 second on the way up, and also at 7 seconds on the way down. Okay. Next thing. What is the initial height of the rocket? Well, initial height is going to be the y-intercepts. Okay, so if you scroll back up here to the picture, it says next to y-intercept, how high off the ground is the object? Okay, so can go back here. Now you can keep scrolling till you figure that out, or you can go to the t-table if you want. And at the t-table, if you put 0 in the x column, you're going to notice that it says it is 0. So probably using the table to find that is going to be faster than trying to manipulate your picture. Okay, how long did it take for the rocket to hit the ground? So if I come back up here, okay, to hit the ground, that's going to be an x-intercept because the ground is considered the x-axis. Okay, and you don't want the x-intercept that's on the negative side. You want the x-intercept that's always farthest on the right side. Okay, so we want an x-intercept that's on the positive farthest right. Okay, so it's x-intercept. Remember, it's the farthest one on the right. Okay, so here you can keep doing this till we get there. And we're back over here. And boom, it looks like the farthest one to the right is going to be at 8. So over here, you would say it takes 8 seconds. Okay, let's go to the back side. All right, on to the back side. Once again, we're going to go type that equation into Desmos. So remember, don't use t's, use x's. So negative 16x, oops, sorry, wasn't typing in there. Negative 16x to the second plus 96x plus 200. Okay. Find the time it takes for the ball to reach the max height. Okay, so that is the line of symmetry. Okay, so line of symmetry. We're going to be looking okay, so here is my vertex all the way at the top. And it looks like how long, that's the x value of the line of symmetry. So that would be 3. So it'll take 3 seconds to reach the highest point. Find the max height. Okay, so that's the y of the vertex. So if I go back to my vertex, the y number is 344. So 344 feet. Initial height. Okay. Initial height. Initial height is the y-intercept. I forgot to write that down. Initial height is y-intercept. Okay, you can keep scrolling here, but then it looks like it's really hard to tell where my line actually crosses the y. So you'd have to stretch it apart farther like this, or it might be easier if you just go to the table and you come over here and you see, oh, right here next to 0, it says 200. So then I would say it is at 200 feet. The amount of time it takes for the ball to hit the ground. Well, to hit the ground, that's the x-intercept farthest on the right. And then we can also so I'm going to go back down. Oh, hold on. There we go. Got a little happy with my scrolling there. Okay, so x-intercept farthest on the right. It will be about 7.6 seconds. When will the ball be 324 feet off the ground? So we're basically saying y is 328, and our job is to figure out x. Okay, so we can keep sliding up here till we get to 328. Oops, a little too much. 25, 26, 27, 28. So 328 right there. On the way up, it's going to hit at 2 seconds. And straight across on the way down. It's not giving me that point, but you can see 2, 3, 4. So it looks like it'll hit at 2 seconds and 4 seconds. Okay, last one. Let's go type that into Desmos. So like I said, hopefully the hardest part is just figuring out what is the question asking me to figure out, and then how do I get that off of my picture from Desmos. Okay. There we go. Oh, this is a small picture compared to the other ones. Yeah, look at that. Okay, for this one, it says, what is the max height? Max height is the y value of the vertex. So if I look back here, here's my vertex, and the y value is about 2.1. So this is Little jumping mouse can jump 2.1 feet. How many feet does it take the mouse to reach his max height? Okay, well, let's see here. How long? That's our line of symmetry. So I'm going to go here, and line of symmetry is the or the x value, sorry, x value, and that is 3.25. Okay, initial height. Initial height is y-intercept. Okay, this one you can go to the t-table, or this one's easy to tell on the graph, and we're starting at 0. So initial height is y-intercept, and we're starting at 0. Okay, can the mouse jump over a fence that is 3 feet high? Hopefully everyone says no, because the max height of the jump is 2.1 feet, which is below the 3-foot high fence. At what distance will the mouse hit the ground? Well, that is the x-intercept farthest on the right. So the x-intercept farthest on the right is about 6.5 feet. Done.